Hey there, year 11s. In this example now, we're going to do another exponential model, and this model is called radioactive decay. So this talks about how a substance will reduce itself over time. So the radioactive material decays over time, which implies that because it drops down, that's an exponential that has a negative power. So y equals 2 to the power negative x, for example, or y equals 3 to the power of negative x. That just means it drops down over time. And in our particular case here, radioactive decay talks about half-lives. So that means that you are saying that for over time, it is dropping by half. So it keeps halving itself each time. And so in this particular case, you can actually see why the model writing half is the same thing as writing 2 to the power of negative 1. And that gives you 2 to the negative x. And that's why in the example, you can see the model has base 2 with a negative, so it's halving. And that's what it's trying to say. It's halving this radioactive value. So A0 is obviously how much you start off with, so how much of the amount you start off with. And you half it over time. Now there is a K value, which is a dilation factor that we don't know. So that changes the rate over time. And then obviously A is the final value, and T is the time that it takes, usually in years. Okay. All right. So here we go. Let's answer this question using this model. So after 1,000 years, so we've got T is equal to 1,000 years. The sample radium decayed to 64.7% of its original mass. So original mass, we don't know. I'm just going to write A0 as its original mass. And then you've got find the half-life of radium-226. It's 64.7% of its original mass. So that means A, after 1,000 years, is now 64.7% of A0. So if you wrote that mathematically, that is 0.647, because that's dividing by 100. Of means times, and that's A0. So using the model that they've given us, they said A is equal to A0 times 2 to the power of negative KT. K is what we need to find out because that's a constant, and they've given us enough information now to solve it. So here we go. A, which we know is 0.647 times A0, is equal to A0 multiplied to 2 to the power of, and I don't know what negative K is, but I do know what T is. It's 1,000. Okay, so simplifying this, we can see that if I divide both sides by A0, it conveniently cancels out to be 1. And so your next line then becomes 0.647 is equal to 2 to the power of negative K times 1,000. And to get rid of the exponential base 2, I'm going to do logarithmic base 2 on both sides. Okay. Maybe I should write it like this to help you guys see. Let's move it down a bit. And then I'm going to move this one just over a bit as well. Like that. And from here, let's do it. I'm going to do logarithmic base 2 on the right, logarithmic base 2 on the left. And we can see here that the log 2 and the base 2 will cancel out, so you get negative K times 1,000. And over here, it's log base 2 of 0.647. Okay, and then divide both sides by a negative 1,000. So K is equal to negative, so dividing by 1,000 of log base 2 of 0.647. Okay, so that's what K equals to. So if we did this on a calculator, approximately, what is this equal to? Let's work it out. What was it again? It was negative 1 on 1,000 multiplied to the log base 2, I think it was, of 0.647. Is that right? Yes. And that works out to be just about this much in value. So now we want to keep it in exact value. So don't try to change it. Don't change it to decimals and round it off. Okay, so I'm just putting it here so that we know what that equals to. So let's just say k is this entire value. Right, 0. It's roughly 3 zeros. 6281. I'm going to do approximately. Okay. So we're not going to use that value. We're going to stick to the exact value. That is the key component. So now we have k. So to answer the question, when they say find its half-life, we know that half-life, okay, so half-life just means 50% of the original mass, which is A0. And my pen stopped working. This is really annoying, really getting somewhere, but I'm going to have to restart my computer. So hopefully you got up to this point. I'm going to do a part 2, okay?